In this video, I will give a brief introduction to the field of affective computing. According to one of the founders of this discipline, Rosalind Picard, affective computing is computing that relates to, arises from, and deliberately influences emotions. In this case, we're speaking about robots which can detect emotions, express emotions, and handle emotions. We could turn to our agent model in which a robot, an agent or a robot had sensors to detect its environments, had actuators to act on that environment, and some kinds of intelligence to handle all of this. So in this case, if we apply the agent model, the robot, which is an agent, must be able to detect human emotions, to express its own emotions, and to do it in a way that what the robot expresses is gets relation with what it detects on the human and the general objectives of the robot. But you may think, is it possible that a machine, a robot, can detect human emotions? Well, the answer is yes. What does the robot need, or any machine, to detect emotions in humans? Well, it only needs two things. First, that those humans' emotions has some external sensitive manifestations which the robot can detect. And second, that those external sensitive manifestations of humans' emotions follow a pattern. And the answer to those two questions is yes. Humans' emotions have external manifestations. For example, we use different words or intonations, or our face changes. But there are also some other more subtle manifestations, such as, for example, heartbeat or oxygen saturations. And robots can use sensors to perceive those manifestations. Robots use cameras or microphones so they can get an image of our face or the sounds of our voice, including words and intonations. And there are also more specialized sensors, such as, for example, photoplethysmography. And although with slight cultural changes, human emotions, in fact, follow patterns. And that's not that strange, because if we humans can detect emotions in other humans, it's because that emotions express via recognizable patterns. And robots use sensors to detect the face, sound, etc. And we use machine learning to perceive or to detect those underlying patterns in the external representations. So robots can, in fact, detect and somehow understand human emotions. And robots can express its own emotions or simulate its own emotions. Of course, they can use spoken language with voice, with its words and intonations, and they can also use some kind of expressions in their faces. In the case of simple robot, that faces of that expressions is that slight changes in the shape of its sides or, or its mouth, not much more like an emoji. But in advanced robots such as Ameca or Sophia or Geminoids, that expression can be closer to what we humans do with our faces. And social robots also use a gaze, gesture, proximity, etc. And to handle effectively the computing of that motions, affective computing benefits from the existence of psychological models of emotions. In future videos, we'll speak about that psychological models of emotions and the technical subtleties of emotion detection and expression. Affective computing is a field with a big overlap with human-robot interaction or with man-machine interaction. We could even consider it as a subset of affective computing, a subset of human-robot interaction or man-machine interaction. So when in future videos we speak about how robots handle emotion, detect it, or express it, in fact, we will be speaking somehow about affective computing. So affective computing does not end here, and there are a lot of things for us to see in future videos.